Assalamualaikum and how are you everyone? Today our group will present our assessment one, which is fundamental principle of counting and fundamentals of logics. So our group consists of 5 members and we will present our solution and solution to 4 main questions that divide into part A and part B. So in this presentation, we will explain step by step how we solve each problem and justify our reason using permutations and justify our reason using permutation combination through table logical agreement. Also connect each concept to real life applications such as password security and system authentications. So we have also redesigned all the original questions with our own custom scenario to make them more relevant and engaging. So let me now introduce our group members. Alright, so our group members is my name is Muhammad Azrul Syakwan bin Abdul Ghani, and second one is Muhammad Arif Fitri bin Suhaimi. Third one is Muhammad IZZAT Hakimi bin KHAIRUDIN, and the fourth is Muhammad Danial bin Abdul Kadir, and the last one is ALIF IMRAN bin THAFFAWI.
Okay, my name is Arif bin THAFFAWI. My matrix number is 2025164661. Next, I will present about part A, question 1. This is our chosen scenario that we make together. There is a university sport committee need to assign 3 distinct leadership. That is captain, vice captain, and treasurer, chosen from 8 athletes. Next, no student can hold more than one role. For example, like like for example, Amir cannot be captain and vice captain at the same time. They need to hold only one role for each of them. That is an athlete for each of them. Next, we move to the first task, that is permutation or combination justification. For our scenario, this is a permutation because order matter. For example, captain and vice captain and treasurer are distinct positions. So, for example, like Alice as captain and Bob as a vice captain is different from the reverse. Each total we have a total 8 athletes, and each of them must have only one role for each of them. They cannot have a multi role. Next, we move to task B. There is number of ways if each role is assigned to a different student. So in our scenario, there is a permutation and order method. So we use a permutation formula, and permutation formula are n factorial divided by in bracket 8 and n minus r close bracket factorial. So in our scenario, we can get 8 uh, 8 student, that is our n, and although there is captain, vice captain, and treasurer, there is 3 roles, so it will become our R. So uh, we can insert n and r into permutation formula, and it will become 8 factorial divided by in bracket 8 minus 3 factorial outside the bracket, and the answer we can get is 336 order for each role is assigned to a different student. Next, we move to the third task. That is, 2 particular students must be in the committee at the same time. In our scenario, we have 8 students, and let's say we chosen 2 students. So, and our scenario, there is this is a permutation and order matter. So there is 3 steps that we can make for for this task. So for the step one, we are chosen role A, let's say captain. We are chosen role A, so there is will be the student A has been chosen to become a captain. So uh, uh, any student cannot be the same role as the student A. So step two, we must assign a second student, but it cannot become a captain because the student first has become the captain. So the second student it will be vice captain and treasurer. So the remaining of role are two. Next, we move to the step three. We must we have three role, and student A has taken captain and student B has chosen vice captain. So we have one remaining role, and by doing so we can the total student we have is 8 student, and we have chosen we have chosen student A and student B, and there is only one space. So the total student that is 8 minus the total student that we choose earlier, there is 2. It will become the 6 student. So it will become a six way. So in conclusion, uh, 3 times 2 times 6, it will become 36 way for student to be in the same committee at the same time.
Now I will continue the presentation on part A, question number 2. So the scenario given that a company login system require a password with 2 uppercase letter starting from A to Z and 3 digits number starting from 0 to 9 with no repetition allowed anywhere. So the 5 character can be arranged in any order. We are moving on to the calculation. So number of valid password based on the question given earlier. So choose 2 distinct letters in order. In this scenario, we use permutation because there is the correct one how to calculate in this situation because we don't want any repetition only. Um, Permutation or easy words, we use P bracket 26 comma 2. How do we get 26? Is in an alphabet there is a 26 of a total in total of alphabet A to Z. That's why it is 26. And comma 2 based on the question equals to 26 times 25. How do we get 25? Is because the first one is A to Z. We already used A. We don't want to repeat it again. So on the second position, we start from B to Z. That's why in total is 25. So 26 times 25 is 650. And then we choose the 3 distinct digits in order. So P brackets 10, 3. Like the first one is exactly the same. So 10 times 9. We just minus 1. And then 9 minus 1 is 8. So 10 times 9 times 8 equals to 720. So choose position for the 2 letters amongst 5 positions. So now we use this a vertical bracket. So 5 on the above and 2 on the bottom, meaning that 5 times 2 equals to 10. So in total, 650. Everything we plus it together, 650 times 720 times 10 equals to 4,680,000 ways. Now we will tweak the question a little bit. So passwords have at least one vowels, which is A, E, I, O, U. So the password with no vowels, only consonant, from the first one, 26 minus 5, because we want to put away all the vowels. We don't want to include it. So that's why in this scenario, so permutation bracket 21, comma 2, the same like the question before, equals to 21 times 20, in total of 420. But the digits will still gonna be the same because a digit is number, not alphabet. And the position pattern will still be the same. So no vowel count equals to 420 times 720 times 10 equals to 3,024,000. For conclusion, because we only want at least one vowels, we minus it from the total that the first one from the total of the first one that we get. So conclusion, 4,680,000 minus 3,024,000 equals to 1,656,000. A total of passwords that we can be created. Now we will allow the repetition and compare the result. If the repetition is allowed, the letter should be 26 power of 2, because we don't care about the repetition anymore. So it will equals to 676. While the digit, it states that 3 distinct number, 10 power of 3 equals to 1000. But the position pattern still gonna be the same in total, which is 10. So everything we times it together, so 676 times 1000 times 10 equals to 6,760,000 in total of password that can be created. So in comparison, logically that something that we allows repetition must be more than the one that without repetition. That's why the first one that we created is less than this one. So allowing repetition can increase the total number of password, but weaken the security by enabling, for example, pattern like this, AA123. It makes it weaker password because we can guess it easier compared to something that we don't repeat it again. Okay, that's all from me. Now my team member will continue the presentation.
Assalamualaikum and good day everyone. Today I will present to you part B question 3, which is this question is about logical segment and truth table. We are given to us a four simple segment, which is P, the firewall is active, Q, the network is slow, R, the user has admin right, S, the user can upload files. Our task is to read a truth table, decide the type of segment, and explain the meaning in real life. Now we will construct the truth table for compound logical segment, which is in the bracket P and not Q, implies in the bracket R of S. Truth tables mean we can check a possible situation since we have four variables, which is P, Q, R and S. We will have 16 possible combination for each row. We will write neither true or false. Then we calculate step by step using logical like AND or AND not. This help us see whether the whole segment is true or false in each situation. Here is the example for truth table we use. Now, after completing a truth table, we look at the final columns. We can see the final column has put true and false values. There is at least one false value, and as all the value is true. So the segment is not always true and not always false. Therefore, the segment is called a contingency. This means the answer depends on situations. Now let's understand its meaning in real life situations. The segment means if the firewall is active and the network is not slow, then the user has admin right or can upload the files. In simple word, when the system is working normally, only user with permission can upload files. This help keep the system safe and controlled. In the conclusion, we have created a truth table, found that the segment is contingency, and explain its meaning in real life situation. Thank you.
Alright, hi everyone. My name is Muhammad Daniel bin Abdul, and my matrix number is 2025 397 and 075. So I'm gonna explain about part B, question 4, which is logical argument and validity topic. Alright, now we move to part B, question 4. The scenario, statement 1, if the fire alarm activates, then the sprinkler system turns on. Statement 2, if the sprinkler system turns on, then the water damage is minimal. Statement 3, if the emergency power fails, then the fire alarm does not activate. Statement 4, the emergency power fails or the backup generator is running. Statement 5, the backup generator is not running. So we analyze the situation. From statement 4 and 5, it say power fails or generator runs, but the generator is not running. So we conclude that the emergency power fails. Next, from statement 3, if emergency power fails, then the fire alarm does not activate. So the fire alarm does not activate. Because the fire alarm does not activate, the sprinkler system will not turn on. And if the sprinkler system does not turn on, the water damage is not minimal. So conclusion to test, therefore water damage is minimal. Alright, from this slide, I'm going to explain about argument using symbolic logic. So as we can see here, F will represent statement of the fire alarm activates. S represent the sprinkler system turns on. But W means water damage is minimal. E means emergency power fails. And G, the backup generator is not running. So the premises, F implies S implies W, E implies not F, E or G, and statement 5 or premise 5, not G. So conclusion is W. And now the conclusion we want to test is W. So we should try to solve step by step. So from premise 4 and premise 5, E or G and not G. So E is true. From premise 3, E implies not F. So not F is true. From premise 1, F implies S, but F is false, so we cannot get S. From premise 2, S implies W. Since S is not true, we also cannot get W. So we cannot prove W. Therefore, the conclusion W is not valid based on the premise. Alright, so from this slide, validity using rules of inference. So step 1, statement E or G. So the reason, we should look back at premise 4. So step 2, not G. And for the reason, we can look back at premise 5. Alright, now step 3, statement is E. So reason, we use this disjunctive syllogism from step 1 and 2, and we will get the statement E. So step 4, E implies not F. So to get E implies not F, the reason, we can go back to premise 3. Step 5, not F. To get not F, we should use the formula of modus ponens from step 3 and 4. And then we will get not F. Step 6, F implies S. F implies S, we can see from premise 1. Step 7, we cannot conclude S because the reason is not F makes F implies S vacuously true. So step 8, statement is S implies W. The reason, we can look back at premise 2. Step 9, we cannot conclude W. The reason, because S is not proven. And step 10, the statement is argument is invalid. And the reason is W does not logically follow. Alright, now we move to the next slide. Validity using truth table. So to prove invalidity, we need one counterexample where all premises are true but the conclusion W is false. So counterexample row, let E equal to true, which is emergency power fails. G equal to false, which means generator not running. F equal to false, which means fire alarm does not activate. S equal to false, which means sprinkler does not turn on. And W equal to false, which means water damage is not minimal. So now we check all premises. F implies S equal to true, S implies W equal to true, E implies not F equal to true, E or G equal to true, and not G equal to true. Alright, so now we are moving to the final steps, which is verification. So from the table, premise 1, expression is F implies to S. Substitution, false implies false, and the result is true. Premise 2, expression S implies W, and substitution false implies to false, and the result is true. The premise 3, expression E implies to not F, substitution true implies not false, which will be true implies true, and the result is true. So premise 4, expression E or G, substitution true or false, and the result is true. Premise 5, expression not G, substitution not false, and the result will be true. So all 5 premises are true, but the conclusion W is false. That proof the argument is invalid. A valid argument can never have all true premises and a false conclusion. Alright, so that's all from our group. Thank you, and we really appreciate your time. Thank you.